We have previously seen that melting of continental ice is contributing to the rise in sea level. Concerning the ice pack melting, this one doesn't influence this phenomenon. How is it possible? Let's take as an example a glass filled with water and ice cubes, symbolizing the pack ice. When the ice cubes melt, will the water level rise? Or will it go down? Or will it remain the same? For this, we will call Vs the submerged volume of the ice cube in the water, and Ve the volume of the ice cube that has emerged in the air. The total volume, V tot, of the ice cube will be the sum of Vs plus Ve. Will the volume of the ice cube once melted, so V total, be greater or not than the submerged volume Vs? It will therefore be necessary to calculate those two volumes. Let's start with the volume of liquid water. According to the mass conservation principle, we know that in any case, the mass will not change during the ice cube melting. In other words, the mass of the ice cube will be the same as that of the liquid water resulting from its melting. Since m equals ρ, which is the volumic mass, by V, the volume, we can write that m equals ρ ice by V total equals ρ liquid by V liquid. And then V liquid equals ρ ice by V total divided by ρ liquid. Let's calculate the submerged volume of the ice cube. Since the ice floats on the water, the forces exerted on it are in equilibrium. On one side its weight, and on the other side the Archimedes thrust. As a reminder, the Archimedes thrust is the vertical upward force equal to the opposite of the weight of the fluids displaced. It occurs in water as well as in the air. Concerning our ice cube, the Archimedes thrust in the water will be equal to the opposite of the weight of the volume of water displaced by the submerged volume of the ice cube, Vs. In the air, the Archimedes thrust is equal to the opposite of the weight of the air volume displaced by the emerging volume of the ice cube, Ve. So, this Archimedes thrust is equal to m, displaced water, by g, by uz, plus m of the displaced air, by g, by uz. G corresponding to the gravitational acceleration and uz to the vertical vector directed upwards, thus the opposite of the weight of the water displaced. We know that the weight of the displaced water is equal to the density of the water multiplied by the volume of water displaced, which means the submerged volume of the ice cube. This is the same for the volume of displaced air. We can then write pi equals ρ liquid by Vs by G by uz plus ρ air by VE by G by UZ. The second component of the equation corresponds to the Archimedes thrust of the volume of displaced air. It can be neglected given that raw liquid is 1 ton per meter cube, which is 1,000 times more important than that of air, raw air being 1 kilogram per meter cube. Keep in mind that the ice cube floats on the water, meaning that the two opposite forces are at equilibrium and their sum is equal to 0. We can thus write dρ equals P, the weight, plus pi, the Archimedes thrust, which equals minus rho ice by V total by G, plus rho liquid by Vs by G. Vs equals rho ice by V total divided by rho liquid. Let's compare the submerged volume of the ice cube and the total volume of liquid water once the ice cube has melted. According to the mass conservation principle, we previously said that the volume of liquid water resulting from the complete melting of the ice cube is equal to V liquid equals rho ice by V total divided by rho liquid. We have also demonstrated that according to the equilibrium of the two forces, so weight and Archimedes thrust, the submerged volume of the ice cube is equal to Vs equals to rho ice by V total divided by rho liquid. Since the two equations are the same, we can conclude that the submerged volume of the ice cube is equal to the volume of the liquid water resulting from the melting. It means that in the context of climate change and ice melting, even if the pack ice melts, the water level remains the same.